Okay, in this do now we need to find x, and what I see in this circle is an isosceles triangle because I have two congruent angles, and it's also denoted that the two radii are also congruent, but I already knew this because opposite congruent angles are congruent sides. So using what I know about triangles, the sum of three angles is equal to 180. I know 2, which is a sum of 60 degrees. If I subtract that from 180, I get 120. And these two angles right here are adjacent to each other. Their sum is equal to 180 degrees, so I'm going to subtract 120 from 180, and I get a difference of 60. And this is a central angle, and here's the arc that it intercepts, so that means x is equal to 60 degrees. Okay, so the second theorem we're going to take a look at is called the Inscribed Angle theorem. And what we want to do or be able to do is to define and identify an inscribed angle, apply the inscribed angle theorems in order to find angles, and their respective arc measures. The measure of an inscribed angle is half the measure of the intercepted arc. Okay, so here is the inscribed angle. What I'm outlining in red here, it looks like a hairpin inside of an eyeball. The vertex is on the circle and extends out to A and C here. So this is 1/2 the measure of arc AC. Okay, and this is the arc that it intercepts. So if the measure of arc AC is equal to 100, then what is the measure of angle ABC? Well, it's 1/2 the measure of its arc, so that is 50 degrees. Theorem 2. If an inscribed angle intercepts a semicircle, then the angle is a right angle. Okay, so we have a diameter here of AOB. We know that the semicircle or half circle here is 180 degrees, so is the measure of the line. And here's my inscribed angle. And because it intercepts this arc right here, AB, that's a semicircle, it's 1/2 of 180, so that's where we get the right angle 90 degrees. And if we have a 90-degree angle in our triangle, then we have a right triangle, and anytime you need to find a third missing side, you can always use Pythagorean's theorem, so don't forget that. And that's what I got here, a squared plus b squared equals c squared. So theorem 2b. If two inscribed angles intercept the same arc, then they are congruent. So as you can see here, we have angle ACD. Okay, one hairpin that's inside the eyeball. And we have another angle, ABD. So that's another hairpin inside the eyeball. Intercepts arc AD. It's the same arc, and they're equal to 1/2 the measure of their arc. These two angles are congruent. Theorem 2c. A diameter perpendicular to a chord bisects the chord and its arcs. So here's the term bisect. So these are two congruent parts right here. And we also have right angles. And in some cases, I've seen where there's a line drawn here. You end up with a right triangle and you're able to find out some information. So it all depends on the situation. And because these two are congruent, these two parts of arc CD are congruent. Okay, we need to find W, X, Y, and Z. I have some chords in here that are connected and create a triangle inside the circle. I have a central angle here, ABC. Here's the arc AC that it intercepts, so that means that angle is equal to 88 degrees divided in half. So this is 44 degrees. I have two angle measures now. I can subtract their sum from 180 and get angle Z. That is 56 degrees. Okay, so this is an inscribed angle, angle BCA, and it intercepts arc W. So W, well, angle Z is equal to 1/2 the measure of arc BA. So all I have to do is double Z. So 56 and 56 gives me 112. So that's what W is. I have to work backwards in that one. And Y is double the inscribed angle BAC. So that is 160 degrees. And there you have it. Theorem 2D. Congruent chords have congruent arcs. So here are my two chords. I'm telling you that they're congruent, so that means the arcs that are on the outside here are also congruent. Okay, so since I know that these two chords are congruent, I can assume that their arcs on the outside here are also congruent. So that means x is equal to 100 degrees. I need to find the measure of angle A. So that is an inscribed angle. That's 1/2 the measure of its intercepted arc. So it intercepts arc BC, which is 100 degrees. So angle A is equal to 50. Angle B intercepts arc AC. So 160 divided in half is 80 degrees. And angle C intercepts arc BA. So that's 100 degrees divided in half is 50 degrees. And I already knew that this was 50 degrees anyways, because these two sides are congruent, and opposite congruent sides are indeed congruent angles. For this theorem, 2E, parallel lines cut off congruent arcs. So if you're told that you have parallel lines, you can assume that you've got arcs congruent in between. So let's practice some. We're looking for x. You have to identify that this is an inscribed angle. And you also have to identify that this is a central angle. So central angles are equal to their arcs. That means this is also 90 degrees. And the inscribed angle is 1/2 its measure, so that's equal to 45 degrees. Okay, so I see an inscribed angle right here. That's 1/2 the measure of arc BD. So all I have to do is double angle A, and I get 70 degrees is equal to Y. I also have another inscribed angle that intercepts the same arc BD. So that means angle A and angle C are the same angle. So this is 35 degrees. And since it says that AB is parallel to CD, so AB is parallel to CD, that means the arcs in between them are congruent. I already found that Y was equal to 70 degrees, so I can assume that angle, or Z, has a value of 70 degrees as well. And the last thing that I can find at this moment in time is S. So angle S is an inscribed angle. I see the vertex on the circle that intercepts arc AC, which I just found to have been 70 degrees. So now I know that angle D has a value of 35 degrees if I take 1/2 of 70. So we want to find the following angles, A, B, and C. I see a diameter here because it goes through the center of the circle. Here's my semicircle, 180 degrees. That means angle C is a right angle. I see that these two are congruent, so that means I know that the sum of the two acute angles of a right triangle is equal to 90 degrees, and in order for them to be equal, they would have to be 45 degree measures. The ratio of BC to AB is 4:1. What is the measure of angle ACB? Okay, we're not going to be able to complete this problem at this time because when I filtered in these PowerPoint slides, it doesn't appear that this diagram filtered in correctly. There's supposed to be a circle someplace here, and I don't remember what this looks like, so we're just going to skip this problem at this time. Okay, we're at our final slide, so that means associated work is going to need to be completed in class, so I will provide that to you when I see you next.